Hey there, YouTube. So today we're going to walk through a very standard set of considerations that basically scope out how you should treat psychological assessment data when you're asked to interact with it in some way. You can think of these as first steps that you should always engage in when someone hands off data to you, even if that person is you yourself. I'm not going to spend a lot of time on the outline on this one, but we'll be focusing most of the hands on portion of the tutorial on the last four elements here, which collectively are the first steps you should always apply with assessment data. The first two elements here are just recommendations for what your expectation should be when working with assessment data. So, if you're asked to work with data that represents responses to a psychological test or inventory, you're going to have some sense of comfort if you know the data. Often, however, you're going to be asked to work with data that someone else has had some level of control over, typically either through collection or some degree of holding the data. Although you may feel more comfortable with data that you've had personal control over, that's likely a bit of a false sense of ease because data can get messy in all sorts of different ways. So it's really a good idea to keep a strong sense of skepticism with regard to the integrity of your data, regardless of who's been in control of it prior to you getting involved at this point. Now, you're going to be aided in your psychometric investigation if you have access to a scoring key. This is the roadmap that tells you how to get from raw item responses to an aggregate respondent scale score. Now, take note that we're starting to use technical terms here. So, if raw item response or aggregate scale score or concepts that sound technical, go ahead and take a look at my video on basic psychometric terminology. I'll put a link in the description. So roadmaps are great and they should be helpful, but we're going to maintain our healthy dose of skepticism even if we have a scoring key, because sometimes these are actually wrong. It's somewhat surprising how frequently these have errors. So even if you have a scoring key, you're still going to want to go through what I guess we can call your alpha checks, which is what this video is focused on. So you're going to be skeptical with assessment data you have, regardless of where it came from. The way you're going to leverage that skepticism is through consulting four different resources. This first intro to forensic alpha analysis is going to keep it simple, and we're going to focus on only a couple descriptive diagnostics. Scoring key I've already alluded to. So, the biggie that we're going to probably spend the most time on is not actually alpha, but a secondary index that you'll get with your alpha analysis, and that is the corrected item total correlation. This is far and away the most diagnostic and helpful index in the vast majority of assessment data investigations. These are so important that they're sometimes just referred to as item totals, although that's a little unfortunate because it's a misleading. The item total is simply a correlation between someone's response on an item and their overall scale score. Here we reference the scale score as a total, however, it may also be an average or even something more complex. This is one of those legacy terms that aren't necessarily technically accurate, but we just kind of roll with it. There are as many item total correlations as there are items. The word total is referencing the aggregate scale score, regardless again of how it's actually constructed. Now, it's important to note here that there is an issue with looking at simple correlations between item responses and a scale score because each item contributes to the scale score. And that means that we're kind of cooking the books a bit. We're asking for an association where there's some contamination. The item values are already considered within the scale score. So the total that we look at is actually a little different for each item. Each item has its own scale score computed such that the focal item's scale excludes the contribution of the focal item. This is what the word corrected means in the phrase corrected item total correlation. At least we got that one right. One last thing to mention is that this statistic is commonly presented as an index of item discrimination. That simply means that we expect item responses to track along with the construct being assessed. Low item responses should be associated with low scale scores and vice versa. Okay, so my first run through this pregame presentation focused on alpha and not corrected item totals. If you'd like to see a deconstruction of what alpha actually entails as a psychometric index, drop me a note and we'll do that. For now, let's just say our aim is for this index to be closer to 1 and further from 0, and that's how we're going to use it in our forensic investigation. All right, so let's open up a computer program and see how this stuff should be leveraged when we're first taking a look at assessment data. So to oversimplify, which is a great tool, there's two main ways you can use these four different indices. One, you can consult your scoring key and then confirm that your scoring key looks okay. The second way is more along the lines of the purpose of this forensic psychometrics channel, and that's to try to predict what your scoring key is going to be. So we'll do the first one first, which is to take a look at the scoring key and then try to figure out if it makes sense given our four different indices. The scoring key that we're going to consult first is from what's a fully balanced instrument. And so what I mean by fully balanced is there's the same number of forward and reflected items on this. Now, this is not currently the most commonly encountered type of assessment. Most scales aren't currently fully balanced. In the 1970s, it was a big deal. Psychologists were concerned about something called acquiescence. We're not as concerned with that at this point in time. So these fully balanced scales aren't something that you should anticipate encountering frequently. And these fully balanced scales are ones that really pose problems for us forensically. However, there are kind of tricks that you can pull that we're not going to go over today, but maybe we'll go over in a subsequent video. So consulting our scoring key here, I see that there's 6 items. Again, unfortunately, there's not context with regard to the actual content of these items. If these items had stems associated with them, then it would be easier for us to actually anticipate what the response scale is going to be. So for example, if item 1 said, I love to be around people, and item 2 said, I hate people, you might get a sense that responses there might benefit from reflection such that a high value is always associated with positivity or negativity towards people. We have to choose one of those. Here, I don't have that context, but I see that item 1 that looks a little funny in terms of the numeric sequence here. So it's saying if you see a 1, change it to a 5. If you see a 2, change it to a 4. This is our typical reflected item, or what's sometimes called a reverse scored item. Again, which is a misnomer. It's not the item, it's the response that we reflect. Item 2 looks more straightforward. Item 3 is reflected again. 4 looks straightforward. 5 is reflected. 6 looks straightforward. And if we look at our scoring key scale aggregation scheme here, it says the scale score is just a simple average of items 1, 2, 3, 4, 5, and 6. Include all of them, give them equal weight. However, this R in brackets here is the convention that psychometricians use to communicate to each other that, hey, if you didn't notice it up above, take a look at it now, because I want you to reflect responses prior to your scale level aggregation. So let's go ahead and open up a script file. I'm going to script this as we go, and we'll call this, I guess we can call it balanced. If we take a look at our balance scale, it does look like we have 6 items. And again, these are very small data sets just for demonstrative purposes. There's 9 respondents. And consulting our scoring key, it does look like there's some correspondence here. Item 1, item 1, item 2, item 2, and it goes through 6. Furthermore, we're going to confirm this with our descriptives, but it looks like the responses that the scoring key indicates, it looks like those may be present here within the data set itself, within the small demonstrative data set. So let's go ahead and consider our 3 additional pieces of empirical evidence. Those pieces of empirical evidence are going to be descriptive statistics, the overall alpha itself, but then the corrected item total correlations as well. We're going to use the psych package, which has some very useful tools built within it that correspond with what we're discussing here today. So I'm going to load the psych package, hopefully spell it correctly. And then with my balanced object, I'm going to double check and make sure that there aren't any superfluous variables in here. A very common extra variable that you might see in a data set like this would be a name or a respondent identifier. Another common superfluous piece of information that you might find would be demographics. This looks okay. My scoring key only focuses on 6 items, and I only have 6 items in this data set. First of all, I'm going to use the describe function for our descriptives. And we can annotate this. And I'm going to increase the size of this window so our descriptives come in a little neater. Now, what I'm looking at here is primarily for this, we can come back on subsequent videos and talk about getting a little more sophisticated with our investigation here. But really what I'm looking at is just the minimum and maximum. And I want to see that this minimum and maximum is close to. And with large data sets, it should fully encompass. With smaller data sets, you might not have the full range of values here. But I want to see that this is close to the values that I see in my scoring key. And so I found my scoring key. And so I see these values ranging from 1 to 5 here. And it looks like I also have 1 to 5 in my data set. This is important because if you see out of range values, that may be a mistake, it may be a typo, or it may actually be an indication that missing values had a numerical code. By conventional legacy, SPSS users had a tradition of indicating missing responses by using the number 99, for example. I have also seen data sets where the missing value code will be one value above what the maximum legitimate value is. That could be an issue when you're looking at something as simple as alpha as well. We don't want those values to be read as legitimate values. And so that's why descriptives are important to actually check. So our second and third indices that we're going to look at are our alpha and our corrected item totals. And we'll get both of those from the psych packages alpha function. And it's a very useful function that whose orientation is very much aligned with things that we've been talking about here. And so there's a warning at the bottom. We're gonna ignore the warnings for now and just focus on the pieces of information that I think are most informative diagnostically. So what most people look at when they run an alpha analysis is this, the raw alpha. This is the number that's reported in technical reports and scientific journals. Most individuals are looking for this alpha to conform to a rule of thumb that's roughly 0.7, 0.8 or above. That's a really dangerous lens to use this statistic through because this statistic is so heavily influenced by the number of items in a scale. So our alpha is 0.27. Through any lens, that's not an alpha that's to be desired. So let's actually go ahead and take a look at our diagnostics to see if we can maybe understand or describe away why that alpha is so low. So this is our table that's going to contain our corrected item total correlations. Within this package, the corrected item totals are actually referred to as R drops. These all look lower than what we expect. Now, what you expect really depends on the length of the scale primarily. With very small item scales, the expectation is these are going to be fairly high, maybe 0.7 or even higher. With large item scales, your expectation is 0.3, 0.4 or higher. Now, this is one of the circumstances that isn't at all unexpected with fully balanced scales. What my expectation was that because this is fully balanced, I'm going to actually have corrected item totals that are very close to zero and probably flip-flopping in valence. So some positive, some negative. But if it's of such low magnitude, those positives and negatives aren't necessarily meaningful in and of themselves. I didn't get any valence swaps here, but I did get very moderate valued corrected item totals. So what we want to do now is apply the scoring key and see if anything changes there. It's not a bad idea to bring that up as you are typing your recodes. And again, we're doing this all in script. Scripting is very, very important so you can go back and correct it when you do make a mistake, which you will eventually. And so I'm going to actually reflect items 1, 3, and 5. The way to do that here, easiest way I've found, is to simply subtract the original value from one number higher than the highest possible value. And some people prefer to create a new variable that would probably be referenced as item 1R, item 3R, and item 5R. As long as you script, you don't really need to do that. You want to, however, make sure that you be consistent with your scripting such that earlier actions are requested at higher points in the script and later actions are requested at lower points in the script. So I'm going to go ahead and run these, and we can make a note to ourselves as well. I'm going to make an annotation here on line 7 as well that this is prior to any reflection. Now we're going to ask for our alpha again, and the expectation is our index, our summary index, might look more like what people tend to prefer. And I do see that it's a value that traditionally would be considered acceptable or even desirable. This simply means that there's likely consistency such that people respond to each of the items. If they respond favorably to one item, they respond favorably to the other items. The main diagnostic, again, I want to look at are my corrected item totals. It looks like my R drops are okay. So what we've done is we haven't confirmed, but we have pretty good evidence that the scoring key was accurate, such that items 1, 3, and 5 should be reflected prior to scale level aggregation. Now, if I wanted to compute a scale on this instrument, I could compute that scale as an average of all 6 item responses once they've been reflected, and I would do that here on line 14 or below. Let's go ahead and actually load in the second data set, which we're going to use in a forensic application. So we're going to try to predict what the scoring key is based on our descriptives, our alpha, and our corrected item totals. So I'll make a little note to myself here. And that second data set, I'll call it predict. We'll see if we can predict what the scoring key is. I've read in the predict data file. Let's take a look at that small one and see what it looks like. I should have been a bit more thoughtful in how I created this one. I have 5 items and 5 people. When you're doing demonstrative data, the number of variables should not equal the number of rows. That confuses people. But here I have a small 5-item scale. 5 people responded to it. It looks just visually like the response scale was very similar to the first one. Since I created it, I know what it is. So let's actually go ahead and do our descriptives of this data set. It also doesn't contain any unique identifiers. It's just item responses themselves. So we'll see what type of values we get. I see the 5 items. I see that there's 5 individuals. And here, again, with small data sets, this isn't at all unusual. But I'm seeing that some of these items don't have a full range of possible responses. And so empirically, I'm only getting 1 to 4 on item 2. I'm getting 2 to 5 on item 3. But collectively, it looks like 1 to 5 makes sense. And again, we're not going to consult our scoring key quite yet. Let's go ahead and do an alpha on this object and see what kind of information we get. I'm laughing because I'm typing poorly. We're getting some errors. I showed you a conceptual formula for alpha in the slide deck. The conceptual formula is different. You can compute alpha from that formula, and if I do a video on alpha, we will do that. But the conceptual formula is different from the actual formula and algorithm that the computer program uses. And so this not positive definite error is not an uncommon one. It's an error that's associated with matrix algebra, which is the algorithm that's being performed underneath the hood here when we ask for this analysis. And the author of this package was very like-minded with us with regard to looking at corrected item totals. And this is an error that frequently comes up, and this error is intended to help you problem solve what we're going through here more kind of organically. You never want to do this if you're using this program. You never want to actually run the function again with a different option, which will automatically perform the recodes.
However, it only does that for this analysis. It doesn't do it for scale score aggregation, and so that can actually cause real bad problems. So never do this. We're always going to want to control manually which items are reflected. We're not going to ask any computer program to do that automatically for us. It's a bad idea. It's based on the same premise. They're using empirical associations to predict what your scale probably looks like, but we want to control that. We don't want to actually have that. We don't want to have any computer program try to do that for us. We're going to try to do that ourselves. So if we go and look at our overall alpha, we see again it doesn't look like what we hope it to look like. We'd like it to look higher. Standardized alpha is what your alpha would be if we had standardized these item responses prior to asking for alpha. That simply means if these were z-scores instead of raw scores. That's not typically used in psychological assessment. It's used in situations where your indicators have different scales. And by scales there, I mean response scales. So our alpha is poor. Our corrected item totals don't look that bad. They're of high magnitude. However, one is of a negative valence. And this is really what we're looking for forensically. And this is really only obvious if you have a unbalanced scale. So here it looks to me like item 1 should be reflected prior to scale level aggregation. Items 2, 3, 4, and 5, not so much. I do have a scoring key for this scale somewhere around here, so I'm going to look for it. There it is. So if we now consult our scoring key, we see it looks very similar in construction to the previous one. My scale aggregate is some simple average of items 1, 2, 3, 4, and 5. I see this funky R hanging around here as well. And if I go up to item 1, I see that item 1 is the indicator that the scale author wants us to reflect prior to scale level aggregation. Items 2, 3, 4, and 5, no, they look like they're straightforward. So this is confirming what we suspected when we looked at our diagnostics here in terms of the corrected item total correlations. Item 1 looks like it probably should be reflected prior to scale level aggregation. So let's go ahead and do that. I'm going to steal, since we have the same range of values here, I'm going to steal the code that I used above. We'll use predict for item 1. And then we can run our alpha again. Don't just go up on the previous line and run it. You want to include in your script that you're doing these for different purposes. So if I go ahead and run that alpha analysis, I see that this is, again, more along the lines with standards deemed acceptable within the psychological assessment field. It's a good alpha. And so my R drops, again, look like they're about where I want them to be. So your corrected item total correlation is going to be extremely informative with regard to looking at data for the first time. This is really the index that we want to consult anytime we get data. So I think that's probably it. I just wanted to stress the importance of corrected item totals when you're looking at when you receive data for the first time. This is something I always do with assessment data. It can get deeper in terms of actually exploring more, and I think we'll do that hopefully on this channel. But for a first run through, anytime you get data, use these tools. Don't just look at alpha, but look at those corrected item total correlations. It's presented in textbooks as an index of item discrimination, but really it's a diagnostic tool that you should use to help you understand your data better.
Okay, so that did take a little longer than I anticipated. I'm going to try to keep these sessions to around 10 to 15 minutes each. The point here is to leverage 4 different indices anytime you first deal with psychological assessment data. Those corrected item total correlations in particular are super diagnostically powerful. We'll do some deeper dives in the future on additional screens we can apply when we first get data, But if you first just apply these four, you'll be well on your way to working with assessment data in a carefully competent manner. So thanks for listening. And as always, please drop me a note if you have any questions or suggestions for future topics. In the meantime, happy item totaling and happy psychometricing.